by nature, explorers. The same curiosity that sends us to the stars at the speed of thought urges us to go there in reality. And whenever we make a great new leap, we elevate humanity, bring people and nations together, usher in new discoveries and new technologies. So remember to look up at the stars and not down at your feet.
Happy International Asteroid Day. It's a day, it's a celebration of all those bits of rock flying around the solar system threatening to kill us. So that's always nice, it's always a good thing to celebrate. Only joking. Asteroids are firstly very unlikely to hit the Earth anytime soon, and actually can help us understand how the solar system was made. Although today's date and why we celebrate asteroids on this day is actually because it's an anniversary. It's the anniversary of the Siberian Tunguska event in 1908, which is where it's believed an asteroid or comet, they think it's a comet now, exploded mid-air, creating an explosion that actually flattened 80 million trees, scared cattle, and the odd farmer got blown off his porch. So asteroids, they're actually the leftovers from failed planet formation. The asteroid belt between Mars and Jupiter that we have in the solar system, it was going to be another planet. So this big asteroid belt was actually meant to clump together to be a planet about 4 times the size of the Earth. And it would have been something that we could have seen in the sky, we could have looked at through our telescopes. It may have completely changed the solar system, so maybe we wouldn't be here. So in a way, it might be lucky that we have an asteroid belt instead of, a large planet there. But alas, it failed. It didn't clump together to create one due to a few factors. So instead, we have a huge ring of dry, dusty objects floating around the sun. Now, they come in a variety of shapes and sizes, with only a few of note really big enough for astronomers to see through their telescopes from Earth, from their back gardens and that, so you can actually see them. I'll tell you how to do that later. A few dozen are greater than 125 miles in diameter, tens of thousands are around 12.5 miles, and millions, there are around 1.25 miles in diameter, and loads of smaller bits as well. Now, this might sound like a lot, and although collisions do occur between them in the actual asteroid belt itself, it's unfortunately not like many sci-fi films we see today, like Star Wars and that, when they're flying around and getting hit by asteroids and crashing into each other. Our ones actually, they're quite far away from each other. So if we sit and stand on an asteroid right now, the nearest one to us would probably be around about 600,000 miles away. That's quite a distance. It's actually twice the distance that the moon is from Earth. So I wouldn't worry too much about trying to, fly through it and not get hit. It'll be very unlikely. NASA have got through 100%, so we're all good on that. Otherwise we wouldn't have any planets to look at. All these cool pictures on Google. Now, the biggest object found in the asteroid belt is now classified as both an asteroid and a sort of minor planet. It says, and making Vesta the only asteroid that possibly visible to the naked eye. Ceres is actually now kind of like a minor planet, and that's made Vesta now the only asteroid that's actually possible to see with the naked eye. If you've got dark skies, good seeing, no clouds, with a pair of binoculars, you could spot a few more, maybe like Pallas, Juno or Eros. You'd have to have a really good eye though. I'm not sure I'll be able to spot it myself. It'd just be a white dot in the sky that moves. So to actually see one's quite difficult unless you've got a telescope, really. Now, the best time to spot one is when it's at opposition. It doesn't mean it disagrees with you. What it means is it's when Earth passes between it and the sun. So roughly speaking, it's kind of like opposite the sun to us and therefore appears slightly brighter. You can find out when this happens with each object including planets from magazines, apps, our Facebook or website monthly guides that are on UK Astronomy there. Have a look there, we'll tell you when something's at opposition. What you'll see is you'll see a load of stars, tons of stars. If you're looking around the Milky Way area, even more stars. But make a note of them and look again a few hours later, or maybe in a day or two, and you may notice one has moved in relation to the others. Now, this could be an asteroid, it could be a minor planet, a dwarf planet, all these sorts of things they're making up now. Or if it has a fuzz around it, it could be a comet. If you spot one, look it up on your planetarium program or an app. And if you can't find it, send it to the British Astronomical Association where you saw it and what you think you saw. If they can't find it on their maps, they've got millions of objects all over it. So if it's not there, then you've discovered it and you get to name it. So how cool is that? You could be in your garden, accidentally find a bit of rock flying through space, and have your name on it forever. Or you could name it something like Bob or Kevin, Minions, or Planeteam at Planetface. But that's entirely up to you. Most people have their surnames put onto it, and that's why I have trouble pronouncing some of the names that are out there in space. Now, all asteroids orbit the Sun like the planets, with their orbit being around about 4 to 5 years long, so that's how long they take to do one sort of like rotation around the Sun, or one orbit. Outside the main belt, there are other groups of asteroids, like the Trojan asteroids that move along the same orbit as Jupiter, around 60 degrees in front, and another group 60 degrees behind the gas giant. So either side of Jupiter are actually two clumps of asteroids, kind of like, it almost looks like one's getting pushed by the planet as it goes, and one's getting dragged along behind it by its gravity. There are also a host of others that have a range of orbits. Some are very erratic, moving in really close to the Sun, then getting flung back out again. Some of these are classed as near-Earth asteroids, and they're the ones we tend to keep an eye on that we know about, because they do pass through or quite close to Earth's orbit. Luckily, we aren't there when they do, not at the moment, most of the time, and hopefully it won't happen. There is also a far bigger belt, and it's called the Kuiper belt, and that's extending from Neptune. It is similar to the Jupiter-Mars one, but it's 20 times as wide and 20 to 200 times as massive, so they don't really know how big it is by the sounds of that. So it's absolutely ginormous, and that's where now the dwarf planet Pluto lies. So what are they made of? What are asteroids? Well, you get stony asteroids made of stony stuff, metal asteroids made of metally stuff, and people actually believe they might have been like the start of core of planets, and they're all metal, and then they crashed into each other and broke up again. So it might teach us what the internal, what the Earth and that's made of from the inside, from the asteroids that are left over. And yep, you guessed it, stony metal asteroids. So a bit of both, roughly speaking. As they formed about 4.5 billion years ago, they were quite close to the Sun, or very close to the Sun. So it was too warm for ices to remain solid. So unlike comets that come from far out in a sort of solar system which is known as the Oort cloud, which is even further out, we get dry, dusty asteroids instead of comets. So the comets are kind of dragged in from the far sides of our solar system, and the dusty asteroids are closer, nearer the Sun, so they're drier. And as I said earlier, they come in all shapes of sizes. You've got Vesta and Ceres. They're more spherical and sort of like larger than the others. You've got Eros, which is kind of peanut shaped asteroid. It's got a kind of unstable orbit, and it crosses both Mars and Earth's orbit, and is the first one to have been orbited and landed on by a probe. And as you can see, it looks quite cool. You've got Itokawa. It's around about 600 meters long, 630 meters long, sorry, and 250 meters wide, and is the first to have material collected from it. It's got a rough surface studded with sort of boulders, and we suspect it may be made of rock fragments loosely stuck together. Now, there was one asteroid that flew past Earth named TB145, and it actually resembled a screaming skull, and it flew past in October when Halloween is. Now, it is really just a trick of the light glancing off the rock and the craters and stuff on it. A few people, kind of saw it, and I'm not going to lie, it does kind of send a shiver down your spine looking at this rock, this a skull flying past the Earth during Halloween. Maybe the solar system has a sense of humour, eh? Now, a recently discovered asteroid known as Ultima Thule, or Thule, I like Thule, it sounds better. It was dubbed the Snowman after the images came back from the New Horizons probe that visited Pluto. It went here and looked at this, and it shows that it's actually kind of like two rocks actually stuck together. So we think it might have showed us how, rocks kind of like spin around together in orbit, and then they might have slowly kind of just stuck together rather than crashed into each other and exploded. So it teaches us all about how things are made in the universe, or the solar system. But not all asteroids come from our solar system. One such visitor was a lump of rock named this. I'm not going to try and pronounce it. It was the first interstellar object that we had seen and actually found, and it was spotted after it had actually slingshotted past our sun at over 196,000 miles an hour. That's pretty fast. And we found that it was actually accelerating slightly. So a lot of people were like, it's an alien, it's a spaceship. It's probably because it flew past the sun and picked up a bit of speed. That's what I'm going with. It was suggested from its strange elongated shape and trajectory that it had been wandering through the Milky Way for hundreds of millions of years. So this bit of rock had been flying all around the Milky Way, and it just happened to have got caught up by the sun's gravity and kind of slingshotted out again, and we'd probably never ever see it again. So, on to the part that you guys probably really want to know about more than anything, and that's asteroid impacts, when they hit the Earth. Now, as we know from the dinosaurs, they can cause major global catastrophes and kickstart mass extinctions. Hopefully we won't have one for a while, and if we do, we might be able to do something about it if we spot it, fingers crossed. So I thought I'd just chuck a few of my favourite sort of past impacts that have hit Earth. One of the best and easily visible craters is in Arizona, the US. Now from the sky you can clearly see that it actually looks like some bit of rock impacted there. It's about 1,200 metres in diameter, 170 metres deep, and its rim is actually 45 metres above the rest of the area, so the rim's actually been pushed up 45 metres. It impacted around about 50,000 years ago and at a speed of about 30,000 miles an hour. Imagine that, a huge mass bit of rock, 30,000 miles an hour impacting it. Now in those days, it was grass and woodland, and it was actually inhabited by giant sloths and mammoths, so I imagine that would have scared a few off and probably unfortunately killed a few. Canada, 214 million years ago, a 3-mile size sort of rock crashed a 60-mile wide multiple ring crater into this area. It's now a beautiful nature spot and swimming area, with the central part being actually the peak that is kind of hit by the post-impact uplift. So when it hit, it pushed in, but then bounced up again and created this sort of peak in the middle. Now they believe this is but one part of several impacts across the world at the same time. So there was actually something, maybe a little bunch of asteroids, they all flew in. There's like quite a few impacts that are around almost the same time. So maybe it was part of the same thing that broke up a huge bit of rock. Probably lucky for us, because if it was bigger, it might have taken out the Earth again. Now this impact site in Russia, it may not seem as interesting as the last two, but when a 5-mile wide stony asteroid crashed here, the immense temperature and the crushing shock of it actually caused the carbon-rich graphite that's in the Earth's ground here to become diamonds. So the pressure and the heat actually created diamonds here. Now, although they are only 1 millimeter in size and dark coloured, I've heard that they're not actually for decoration. We actually use them for sort of like technical machinery and things like that. So maybe it's for cutters and stuff like that. So maybe next time you're using diamond cutters, maybe it's come from this asteroid. Now, one of the most famous ones, this is the Mexico impact. Now, although you can't really see any of it yourself, if you go there or go into space, you can't really see it. The scientists actually found it using technical instruments, and it's a 110-mile circle. They found sort of half a circle, and then they managed to find the other half of the circle. That makes sense, 2 halves make a circle. They used carbon dating and showed that the layer was actually about 66 million years old. Now, using some other scientific experiment involving iridium, which asteroids have quite a lot in them, they figured out that a 6.2 mile asteroid impacted here in Mexico, and it was the impact that we had thought happened that wiped out the dinosaurs. So this has actually showed us that this is where this massive impact came in, and it was exact the same time as when the dinosaurs wiped out. Now they say it might have just been a part of the extinction, maybe they're already on their way out a bit, who knows, it might have been global, warming from the asteroid impacting, throwing debris everywhere. But either way, it happened. It just happened to happen at the same time as the dinosaurs then started to die out. So there are about, so far, 190 confirmed craters on our planet. So that's quite scary as you think that all these asteroids, 190 that we've found so far, have hit the Earth already. It sounds scary, but asteroids actually, they rarely hit, as I said, and they can tell us a lot about the solar system, as they are the leftovers of the building blocks of, us. The solar system, planets, everything like that. they're all part of it. Our missions have been sent to get some samples. As I said, there's a couple that have been visited by probes and they've actually picked up samples and are bringing them back to tell us how these bits of dust and rock actually clump together and form the planets and what they're made of and how it works. And as I said, some of the metal ones they actually think are the core of planets that have been smashed up, so it'll help us learn about our own core on Earth. So although they can sometimes hit us and end life or help to end life, asteroids are actually the very things that created us, along with the Big Bangs from stars and a few other bits, supernovas, but they do help. Once they kickstart planet formation, they jump in and actually build the planets. So we should really look at them with wonder, not terror, as they're actually the very thing that created the awesome world that we live on today. So happy Asteroid Day. I hope you enjoyed it.